Hey, welcome back. So this particular video is to discuss the last part of the course, that is transformers and three-phase systems. This one being based on transformers. So without further ado, let's start. So if you remember, the dot convention is for the mutual inductor uh, to specify whether M in the mutual inductance is to be taken negative or positive. In this case, we have the two dots. The current is flowing towards them in both the inductors. So we'll take M to be positive, and when represented in matrix form, the relation between V1, I1, V2, I2 will be this way. So what if we put an impedance on the second port and we wish to find the equivalent impedance on the first port? So again, starting with the two equations that we already had, and V2 equals minus Z times I2, minus sign being taken because of the sign convention followed here. On solving these, we will get V1 bar by I1 bar is an expression something like this. Not a very beautiful expression, but if we take the ideal transformer, that is M square equals L1 L2, and both L1 L2 are very large, we'll get Z equivalent to be L1 by L2 times Z. What does this mean? So ideal transformer, when we talk about M is K times square root L1 L2. If K tends to 1, and all the flux from one coil will go into the other, and this is again the second case where that was here, that is if L1 L2 are very large, the reactance of each coil at omega is much greater than the impedance magnitude connected across it. That is, omega times L2 is very greater than the magnitude of the impedance Z. So if we have a coil with N1 turns and N2 turns, N1 turns in the primary coil, N1 in the secondary coil, from some electromagnetics, we'll get the relation L1 by L2 equals N1 square by N2 square. And on solving the equations again, to get V2 bar by V1 bar, the phasors ratio, we'll get an expression like this. Again, not a very good looking expression, but if we take K equals 1, the ideal case, we'll have V2 by V1 equals N2 by N1, that is proportional to the number of turns. Similarly, since we had the equivalent impedance case, if we take the turns ratio in consideration, we'll have Z equivalent is equal to N1 square by N2 square times Z2. We had this V2 expression derived just now, and if the transformer is lossless, all power from the primary coil will be transferred to the secondary coil. So V1 bar I1 bar product equals V2 bar I2 bar. That is I1 by I2 equals N2 by N1. The inverse relation as we had for voltage now holds for current, inversely proportional to the number of turns. So we have the current ratios, voltage ratios, and the impedance relation as well. So we must also say that DC cannot be used on a transformer. The direct current cannot be used here. Only alternating current can be used. And this was the discussion of transformers. In the next video, we'll see what three-phase systems are. And that's all about this video. I hope that helped, and thank you.